Good morning, students. Thank you very much for your submission of your DPPs. I have started evaluating those DPPs, and I hope few of you started getting emails as well of the evaluation containing my evaluation report. And that I started from morning today, and I'll be in touch with each one of you as long as the questions of these DPPs are concerned. Let me complete the evaluation in the next couple of days. So today what I am going to do is that if you recall that in the last class we have done the differentiation of implicit function and some representative examples, and also we did the same thing for differentiation of parametric functions with representative examples.
And sir, I had two doubts in the first DPP.
Yes, I had a looked into it. I clearly remember. So those two are on the basic, first principle. First principle we didn't discuss so far because that actually needs a prior knowledge of limits. The differentiation what we are doing today is that mostly it is for the requirement of solving numerical problems of physics. Okay, so that will eventually cover when we'll cover limits, and that will happen in another 2 to 3 months from now. I remember this thing, two doubts. In fact, I sent you the evaluation report today morning. Okay.
Yes, I saw that.
We can there I wrote this thing, and I saw there are one silly mistake also happened. I think you have noticed all this stuff, right?
Yeah.
Anyway, as I said in the beginning of the call, that I will be in touch with each one of you for these two DPPs. But today, what we will do, today we will be solving together some problems related to implicit function and parametric function. Is it clear to all of you, dear students?
Yeah.
All right. So I'm going to share the digital board with you, and if you have a couple of minutes, you can just quickly recap how the parametric functions differentiation and implicit functions differentiation actually happen. Okay. And tomorrow, we will start a new topic called integral calculus. Clear now?
Yeah. Yes.
All right. The first question you'll be able to view. It will be available in your screen in few seconds. Please confirm that you are able to view this question, dear students.
Yeah. Yes.
All right. So there are, you need to find dy dx. There are two questions actually here. You see the first one, that x equal to a into theta plus sine theta, and y equal to a into 1 plus sine theta. So that is a parametric function. Okay, with parameter theta as the parameter. If any one of you is having some difficulty to understand the question, never hesitate to ask me. Please feel free to ask me. And you are free to look into, the previous day's class note, where I solved one problem on parametric function. Done? Good man?
Still doing so.
So obviously your answer has to be in terms of theta. Okay. I think I need to assist you here, or if someone is able to do it. Could you please tell me what is the fundamental principle here?
So in the first one, I got 1.
First one you got 1. Okay, that is not a correct answer. Okay, we'll see. But do not worry about whether it is correct or incorrect. Most important part is the learning. So let's look into the first one. Okay. So based on our understanding, what do you know about dy dx? Dy dx should be equal to dy d theta divided by dx d theta. Correct or not?
So I got cos theta by 1 plus cos theta.
That is precisely the correct answer. Thank you very much. Divided by dx d theta. Now, if we look into dy d theta, d theta of what? A into theta plus sine theta.
Yeah.
Divided by d theta of a into 1 plus sine theta. I hope all of you agree to me. Correct or not?
Yeah, shouldn't be a into 1 plus sine theta by a into theta plus sine theta, because dy d theta, right?
Oh,
Yes,
okay.
it should be reciprocal.
I made a mistake. Yes. It should be a into 1 plus sine theta. Correct you are. Yes. I think you are talking about this thing, no?
Yeah.
Yeah. Correct. So a into 1 plus sine theta here. and here theta plus sine theta. Now it is fine, no?
Yeah.
So then you see that A is a constant, so we can take A outside.
Mhm.
If you take outside, then d theta of 1 is what?
0
0. And d theta of sine theta is equal to
cos theta.
cos theta. And similarly, here you will take A out. d theta of theta is what? 1
Yeah.
plus d theta of sine theta is what? Cos theta.
Oh, okay. Yeah.
That is equal to cos theta. As
Cos theta
I
by
hope
1
all
plus
of you
cos
got the
theta.
same thing. Sagnik said though, first cos theta by 1 plus cos theta, since A is not equal to 0. Writing this thing is important, because if A is equal to 0, you really cannot do this thing. And if A is equal to 0, the question doesn't make sense, because then x will be 0, y will be 0. What is there in the question, correct? Anyone has any simplest doubt here? And Divans, you can think of that, what was the missing link? I hope there was a silly mistake. Instead
Yes,
of
so why d theta of theta is equal to 1?
okay, let's go back to, so what is ddx of x power n?
And x to the power n minus 1.
Fantastic. N into x to the power n minus 1. So now d theta of theta power 1,
Ah.
correct or not? Theta means
Yeah.
theta power 1.
Hmm.
So 1 into theta power what?
0. Oh, okay, right. Okay.
All right. Anyone has any further question before we proceed to the next one? Okay. Let's proceed to the next question. That is x equal to e power t into sine t plus cos cot t, and y equal to e power t log t. Take a couple of minutes. That is also not that difficult a question. It should not take much time. Anyone got answer? Mohor?
No, something.
Okay. Ragnik? Good morning. Disha?
So do
Okay. Sujita? Dibansu?
I'm doing so.
Okay. So I think let me proceed, and you can also suggest me that whether you are getting it or not. What is dx dt? For the, let me use a different color pen for the second one. What is the value of dx dt you are getting? Obviously, you know
So I
that.
got et into cos t minus cos x square t plus sin t plus cot t into e to power t.
Yes, even I got that.
That is the value of dx dt you got.
Yeah.
Yeah.
So I think it is, you see it the way I'm doing, then you'll find that what are the scope of improvement. So what is dy dx? That we are aware by this time. It is dy dt divided by dx dt, correct or not?
Yeah.
So now let's first find dx dt. Dx dt is equal to what? ddt of, you know, e to the power t into sin t plus cot t.
Yeah.
Okay. Just a minute. Now the thing is that the moment you find this thing, then what we are going to get it here? So that is equal to e power t into ddt of sin t plus cot t. What is sin t? Sin t is cos t, correct or not? I can
Yeah.
do a bit of step jump now. Cot t is equal to minus cos x square t, correct or not?
Yeah.
Plus sin t plus cot t into ddt of e power t is e power t, correct or not?
Yeah.
So you get e power t into sin t plus cot t, correct or not?
Yeah.
So from here, so that's what you said, e power t is equal to sin t plus cos t sin t plus cos t plus cot t minus cos x square t, correct? Got it? Clear or not clear?
Yeah.
Okay. And what is the value of dy dt? What is the value of dy dt?
Sir, I got e to power t by t plus log t into e to power t.
Yeah, even I got that. Yes.
Correct. So that means in simple terms, you can say it is e power t into log t plus 1 by t.
1/2.
Correct. Correct, you are. So dy dt is equal to e power t into ddt of log t. That is, I can write one step, ddt of log t plus log t into ddt of e power t. Gurman, perfectly fine. Disha, Srijita.
Yes, sir.
So this implies dy dt is equal to e power t, ddt of log t is 1 by t plus log t into ddt of e power t is e power t. So from here, what we can take is that dy dt is equal to, we can take e power t common and we get log t plus 1 by t. Correct or not? So these are the values we got. That one we get the dx dt here and dy dt here. So what we need to do? We need to apply these two and find the value of dy dx here. Correct or not? So from here we get dy dx is equal to dy dt, that is e power t into log t plus 1 by t divided by e power t into sin t plus cos t sin t plus cos t plus cot t minus cosec square t. Correct or not? So from here what we get is that the value of dy dx, because e power t cannot be equal to 0 for any value of t. So that is equal to log t plus 1 by t divided by sin t plus cos t plus cot t minus cosec square t. Correct or not?
Yes.
E power t is not equal to 0.
Yes, I got this.
That is the final answer. And you know, dear students, one thing, I made a mistake while giving the question. There is a typo I made in the question. But I solved it because, see, parametric equation, if you remember what I discussed in the last class, is that the parametric equation has a significance. The purpose of parametric equation is that it actually reduces the number of unknowns. As you see, both x and y are represented in terms of t, one variable, no? One parameter actually. If you change the parameter, you will get different values of x and y, the coordinates. And as you vary t is a real number, you get different coordinates, and now you join those coordinates and you get the graphical representation of the function. Now it has to be a kind of a practical. So the question what I gave, that doesn't represent a curve as such. So instead of cot t, it has to be cos t. That's the typo happened, but as long as the differential calculus is concerned, we can always find it out. Got it? Huh? Okay. Anyway, I think I should move to the next question. If anyone has any doubt in this question, never hesitate to let me know. Otherwise, I should move to the next question.
Yeah.
And we should solve now, solving one differentiation of an implicit function. Okay. So you will get the question in another few seconds in front of your screen, dear students. So just give me a few seconds. And I hope you got the question in front of your screen, right?
Yes.
Yeah. So as you recall, the implicit function where you really cannot express y in terms of x directly and or x in terms of y directly when x and y are together and represented in such manner. These are called the implicit function. And we discussed how to differentiate an implicit function. Now, with these two questions, we are going to see how. Okay. Shall I proceed? Or did any one of you got answer?
I'm doing so.
I got something, but I don't know if it's correct.
Yeah, do not worry about whether it is correct or not. Only you should think about that you have done it, and we should completely understand, the way we have done it. That is what is important. Answer is just, the way of, verifying whether it is correct or not, and then we will learn from it if there is a mistake. Yeah, tell me your answer.
So I got x sine y plus 2x by 3y squared.
I got cos y minus x sin y plus 2x by 3y square.
Okay, I don't think it is correct, both of your answer, but we will see into it. We will look into it. Okay. So let me proceed. Huh?
Okay.
Okay. So let me proceed for the first one here. So what we have learned, is that when it is an implicit function, we just differentiate. Correct or not? D dx. Disha, you have any answer for me?
No, sir.
Okay, let me do it. Okay. Plus x square, sorry, minus y cube, that is equal to 0. No? D dx of 0 is 0. So then what we are going to do? From the algebra of differentiation, we know it is the differentiation of the individual function. X into cos y plus d dx of x square minus d dx of y cube. All of you agree to me?
Yeah.
So this implies d dx of x into cos y. So x into d dx of cos y plus cos y into d dx of x. D dx of x square, so we know that is 2x minus d dx of y cube. So chain rule, d dy of y cube
Into dy dx.
into dy dx. Correct. That is equal to 0. So this implies what? Here also x into d dy of cos y into dy dx plus d dx of x is 1, so it should be simple cos y plus 2x minus d dy of y cube should be 3y square into dy dx is equal to 0. So what we can do is that we can d dy of cos y, that is equal to minus sin y. So this implies, minus minus of x into sin y into dy dx and minus 3y square dy dx. So minus 3y square. All we can have dy dx, that is equal to minus of 2x plus cos y. Correct or not?
Yeah.
So from here, minus minus got cancelled in the both the sides. So it is dy dx equal to 2x plus cos y divided by 3y square plus x sin y. Please have a look into it and do let me know where was the missing link that you didn't get it. What was the missing link? Never hesitate to ask question, as I always say.
Sir, in the DDX of
Yes, please.
the DDX of x cos y had directly put minus sin y. That's why I got it.
No, it is not correct. You understood why it is not correct?
Yes, I got it.
Because you do not, you can do this thing if you consider x as constant, but is x a constant? No.
No. Okay, I understood.
Instead of x, if it is 2, 3, a or some other constant, you can do this thing what you said. Otherwise, you can't do, no?
Yes, I got it.
I hope all of you got it. Anyone has any simplest doubt, never hesitate to ask me. Let me write 3 properly. Okay, now let's proceed to the next one.
So one question I had,
Please.
when we do ddx of cos y, can't we directly do my minus sin y? Why do you have to apply chain rule here? Because you know the value of ddx of cos y, right?
Okay, so then we need to go back to our previous classes, what we discussed. Okay, so here what is the point? ddx of cos y, correct?
Yeah.
ddx of cos y. Now, think about, if I give ddx of cos x, okay, so what you'll do? ddx of cos x, you will do it is equal to minus sin x. Why? Because
Oh,
of,
here it is different because of the functions are different. Okay, fine.
correct.
Okay.
Understood now, right?
Yeah.
Okay, all right. So may I proceed to the next question, dear students?
Yes, sir.
All right. So now I think you need to do it and try for a couple of minutes. Not try, you'll be able to succeed, I know. Okay. Only thing is that you need to have your conscience very clear that whatever the formulas we discussed, what the concept we discussed, just application. Again, you see, whatever I have done, did I apply anything new? I hope it is not, correct? All we have applied whatever we have learned. Gurman, the previous question you understood properly?
Yes, I made a mistake in the last one.
Okay. Mistakes is not that great unless you are learning from that mistake. Learning from the mistake is the most important thing. Mistake can happen. Mistake happens to me as well, you know. But I learned from that mistake. Same thing to happen to you as well. I think I can do it now, or you can verify your answer, dear students. Or you want me to give you some more time?
So just some more times.
Okay. Technique, is it going fine?
Yes, I'm doing.
Disha?
So still doing.
Srijita, is it going fine?
Yes, sir.
Okay. Any point, any question, please feel free to ask me. Okay. I think I should do it now because by this time the answer should have come. So you can verify the way I'm doing and you are doing in the same manner or not. So what we need to do, we need to do, differentiation of both the sides, correct or not? Differentiation of x square minus y square. That should be equal to ddx of c into x square plus y square whole square. Obviously, here, c is a constant. No need to mention here. By looking into the problem only, you need to think of that it is a constant, correct? So, ddx of x square. Ddx of x square is what? 2x. And come on, please say me. Someone can please say me that what is the value of ddx of y square?
Minus 2y into dy dx.
Fantastic. Minus 2y into dy dx. I hope all of you understood why it is minus 2y into dy dx, especially Divanshu.
Yes.
You
Yes.
asked a question, brilliant question.
Yeah.
Okay. So this is equal to what? Next part is important. C into ddx of, x square plus y square whole square. Correct? Clear or not clear?
Yeah.
Okay. So first what you'll do, so here left hand side the 2 into, x minus, let's write 2x minus 2y into dy dx. Here C, if you recall the way I have done it, assume that this is actually a green, circle. So as if you are going to do ddx of green circle whole square. So what it will be? It will be 2 into that
X.
green circle, complete 2 minus 1, correct or not? That entire green circle, power 2 minus 1. 2 minus 1 is what? 1, power 1, into ddx of that green circle. So many times I have said, no? Correct or not?
Yeah.
All of you got it, dear students? Because after that, we may not have time to discuss on all these things again.
Yes.
Okay. So then what is the green circle? It
X
is
square.
nothing but x square plus y square. Srijita, absolutely clear?
Yes, sir.
Okay. So from here, what we get? 2x minus 2y dy dx is equal to 2 into c into x square plus y square. Now ddx of x square plus dd of y square. dd of x square is what? 2x. And dd of y square is 2y into 2x. After this, it is just a simple, algebraic simplification, nothing else. So what we can get is that we see that 1, 2 will get cancelled in both the sides. Correct or not? So we'll get something like this, that y dy dx plus 2c into x square plus y square, 2c into x square plus y square into y dy dx is equal to x minus 2cx into x square plus y square. Correct or not?
One.
Just simplification. I made xy together, sorry, dy dx together, and the other terms together in the right hand side. So from here, what we get? Dy dx is equal to x into 1 plus 2c. Just a minute. I think y dy dx, so it should be minus and it should be plus. I made a small mistake here. It should be minus. Correct or not? And it should be plus. Right, dear students?
Yeah.
Yeah. No, I was correct. So y dy dx plus 2c into x square plus y square. No, I was correct actually. All of you are, comfortable with, right? Correct?
Yeah. Yes.
Absolutely clear or not clear?
Yeah. Yeah.
So then what we get? So we get that dy dx equal to, x into 1 minus 2c into x square plus y square. Correct? Minus 2c into x square plus y square divided by y into 1 plus 2c into x square plus y square. After that, what you can do, you can replace the value of c. What is c? C is equal to x square minus y square divided by x square plus y square. Correct or not? Whole square.
Oh.
So you can apply that value of c and you can simplify further. Correct?
Yeah. Understood.
So this is, all about the solution. Please have a look into it and do let me know if you have any smallest doubt. Because in the next few minutes, I'd like to discuss to solve in some different type of problems. It's not very, difficult. It is easy actually, but the concept is little different.
Okay.
May I proceed to the next part? Dear
Yes.
students? Okay, great. So what we are going to do is that we are going to do a differentiation of a function with respect to another function. Okay. What is that? The differentiation of a function with respect to another function. Let me show you one such example. So I hope you're able to view this question, dear students. You'll able to view, not now. In few seconds, you'll able to view it. Correct, no?
Yes.
Okay. So if you look into it, do I need to increase the font or it is fine, perfectly fine?
Fine.
Okay. Find the derivative of the first one I'm going to do, second one you'll do as a homework, is that 2x minus 1 by x square plus 1 with respect to sine x square. So if we assume that y is equal to 2x minus 1 divided by x square plus 1, and if we assume that t is equal to sine x square, not sine x whole square, it's of x sine of x square,
Okay.
then what we need to find? Can someone please tell me what we need to find?
Dy dt.
Perfect. We need to find dy dt. Correct, na?
Yeah.
So, but y is not a direct function of t, na? So how to find dy dt? Y is a function of x,
Mm.
and t is also a function of x. As
Yeah.
if you can make an analogy, sir, it is a parametric form, sir, where x is a parameter and y and t both are related to this parameter x. Correct or not?
Yeah.
Isn't it? If you recall the previous classes, or
Yes.
we have done a couple of questions, right?
Yeah.
So then, simple thing. So if we need to find dy dt, so what do we find dy dt? So dy dt should be is equal to dy dx
By dt.
by dt dx.
Yes.
Correct or not? Clear or not clear?
Okay.
So that we can give as equation number 1.
Mm.
Now let's find dy dx. Dy dx is not a big deal to find, correct or not?
Yeah.
So let's find dy dx. Dy dx. How to find dy dx? You can apply, multiple concept. You can apply the rule of, u by v, and you can apply the rule of u into v also, whatever, because in that case x square plus 1 to the power minus 1. And Mohor, one small suggestion I have, when I was evaluating, I
Yes.
saw you have done so many u by v that in case of one u into v, you also wrote u by v, right?
Yeah. Yeah.
Okay, so notice this thing. So now, what is dy dx? So let's take u by v form. Okay, so what it will be? All of you are able to follow my statement, na? Satni,
Yes.
Gurman,
Yes, sir.
Isha, Divansu, Srijita. So it is x square plus 1.
Yes, sir.
Okay, great. Into ddx of 2x minus 1. Disha, you able to follow that properly?
Yes, sir.
Minus 2x minus 1 into ddx of x square plus 1. Any doubt here?
No.
Clear, no?
Yeah.
So this implies what? This implies dy dx equal to x square plus 1 whole square into x square plus 1 into ddx of 2x minus 1 is nothing but 2,
2. Yeah.
minus of 2x minus 1, and ddx of x square is nothing but 2x.
Yes.
Correct or not?
Yeah.
Absolutely clear, dear students. Agnik?
Yes, sir.
Okay. Now, if you simplify, then what we're going to get is that you will get, in the numerator, you will get 2 plus 2x minus 2x square. Correct or not?
Mm.
2 plus 2x minus 2x square. So what I'm saying is that from here you can find the value of dy dx is equal to 2 plus 2x minus 2x square divided by x square plus 1 whole square. Clear or not clear?
Yes.
Great. Now what we need to find? We need to find dt dx.
Yeah.
So we found dy dx. Then we need to find dt dx. Any simplest doubt? Because in some of the physics question, you'll come across this kind of situation. Now let's find, let me use a different color pen, green. So then what is dt dx? So t is equal to, so dt dx should be equal to ddx of sine of x square, correct or not?
Yeah.
So this implies dt dx is equal to, first again, I'm not going all this encircled now because we are a little bit matured now, right? So what you can do, ddx of sine x square. What is ddx of sine? Is cos. Cos into x square into ddx of x square, correct or not?
Yeah.
Chain rule.
Yes.
So this implies, dear Divanshu, do you have any doubt that why you are applying chain rule here?
No, sir, understood.
Okay. So then because you asked similar question in one of the previous, that's
Yes,
why
yes.
I'm asking this thing specifically to you. So ddx of x square is nothing but 2x. So 2x into cos of x square, correct or not?
Yeah.
2x into cos of x square. So this implies what? This implies dt dx. Okay, already we found it out. Dt dx is this. So dt dx. Now, if you apply in our equation 1, let me use a different color pen. In our equation 1, if we apply all these things, so what will going to happen? If you see, sorry. Yeah. So what is dy dx then? Dy dx is equal to dy dt. I'm so sorry. Dy dt. So that is equal to what? Dy dx in the numerator.
Yeah.
That means this one, this guy, na?
Yeah.
So what is that? 2 into 2 into 1 plus x minus x square divided by x square plus 1 whole square, correct or not?
Yeah.
And what is dt dx? Dt dx is that 2x into
Cos
cos
x.
of x square.
Yeah.
So from here what we can get? From here we get dy dt is equal to, you get that, 2 and 2 got cancelled, na?
Yeah.
So 1 plus x minus x square divided by x into x square plus 1 whole square into cos of x square. Isn't it, dear students?
Yeah. Yes. Yeah.
Correct or not?
Yeah.
Absolutely clear, right?
Yes.
Yes.
Dear, okay, Gurman.
Yes, sir.
Perfect. So, what about the next question I gave, that differentiate sine x square with respect to x square? You need to do it, and you need to, come back to me before tomorrow, because tomorrow we are going to start integral calculus. But before we conclude our session for today, I just want to show you that how come that perfection will come. Perfection will come, dear students, is only through practice and practice. Believe me, the only way to get perfection is through practice. There is a old saying is that practice makes a man perfect. So, and that I can let me show you how it is. So let me share the screen with you. Just have a look into it. Most of you are already aware of it, but I would like to show you once, because how to get the practice test. DPP though you are getting, so you are doing DPP. All of you are able to view this website of konakclasses.com now.
Yes.
Okay, so just log in as you are all aware of it, how to log in. And after successful login, go to the right. In the right online exam, you know how to appear DPP, that I'm not telling. Go to the right practice test. So here you just give derivatives. You see, continuity and differentiability and right practice test. You see, these are great questions actually. Believe me, the more and more you practice, the more and more you practice, the more and more you get confidence. What happens in practice is that, suppose tomorrow if you get a similar questions, whatever we have done so far, you'll be able to answer very easily, right? Because it resides in your mind. So you'll get 10 questions at a time, you see. And after you giving this one, again you go for the another 10, another 10. Means do not make rest. Go ahead and give test and test and test. And be in touch with me. Things will be perfect. So with this, I would like to, conclude the class for today. If you have any specific question for me? Before I conclude, yeah, please, Mohar. Yeah.
So like I tried this like whatever question I got wrong, I tried that again, but I again got the same answer.
So we can discuss those questions, no? For example, you are talking about DPP 5 and 6.
Yeah, the fifth one that you have evaluated. Like, can you please tell me what mistake I made? Like if I send you the picture.
Okay, I can discuss these things after this class, okay? Because that is a question specific to you. So
Okay.
we can discuss after the class, huh?
Okay.
Correct.
Yes.
Okay. Anything specific what we have discussed so far? If you have any doubt, please do let me know before we conclude our class.
Yes.
Okay. All right then. So I'm going to discuss with you, Mohor, in another few minutes. Okay.
Okay. Yes. Thank you.